Hi children, come on join. Equations. Yeah.
చేయండి ఇప్పుడు.
Balu, look here. Today is different concept. Equations of linear motion. Equations of equations of linear motion. Is it visible? Is it audible? First, you have to message me yes or no. Come on. Equations of linear motion. Equations of linear motion. No. Equations of linear motion. Is it not visible? Now, is it visible? కనిపిస్తుందా? Is it visible? Is it audible? Okay, now see equations. This one linear motion. So what is motion? So in kinematics we discussed rest, next motion. Rest and motion are relative. Distance, scalar, displacement, vector. Then depends on distance, that is nothing but speed. This depends on displacement, velocity. So in velocity, average instantaneous velocity, then okay, next uniform velocity also we discussed. Next acceleration, deceleration. These are the concepts we covered up to now. So today what I am going to say, equations of linear motion. Linear. What is linear? So only single direction. 1D motion. 1D motion. That means in one direction only the motion is there. The body is traveling in only particular direction, in one direction. That means, is it along x-axis? It may be along y-axis. It may be along z-axis. Only single direction. Only one linear. linearly motion. So the body is, for example, like this along x-axis. This is a bus. It is moving along this direction. So this is a linear motion of the bus. Linearly moving. Linearly means it is moving along in one direction. Along in one direction. So we are discussing here equations of linear motion. Equations of linear motion. If any body is moving in one particular direction, only single direction, that is along x-axis, it may be along y direction, the body is going upward. Otherwise, the body is going along x-axis, otherwise the body is going along y-axis. So like that, only single direction. So we can apply linear equations for linear motion. So I will write here first one v equal to u plus at. V equal to u plus at. V equal to u plus at. Second, see this is velocity, this is acceleration, this is time. So here write this equation, you copy it. Here u equal to initial velocity, u equal to initial velocity, whereas v equal to final velocity, a equal to acceleration, t equal to time. See, this is, we have the kinematic equation 1, that is v equal to u plus at. Here u is initial velocity, v is final velocity, and a is acceleration, t is time. So here what equation gives the information? What the equation will give the information? Simple. A body starts with u initial velocity. After time it reached, for example, it starts with the initial velocity u. After time it is traveling and it gets velocity to v, that is v velocity means v is the final velocity. See, during the motion it starts at a and ends at b. At point a it has velocity u. At point b, this is a reached position, that is the velocity of that position is v, that is final velocity. How much time there is change in velocity, how much time taken, that is t time, t seconds. See, u initial velocity, 5v final velocity. So for this u to change to v, u velocity change to v, it takes time t. How much accelerated? A is the acceleration. So here, for this simple, I am giving this graph. Initially the body starts with u, small u. After time t, it reached, after time t, the velocity goes to v. It starts with initial u, finally it gets, it reached p. So during this one, the body accelerated with uniform acceleration throughout the journey. Throughout the journey, the body accelerated with single acceleration, that is uniform acceleration. So equations of linear motion, we can apply uniform acceleration bodies only. That means throughout the journey the acceleration should be same. That means initial here to here, throughout the journey the acceleration should be equal to a. With the constant acceleration it has to move that body. This is the how we can use this equation. This is kinematic equation 1. Equations of linear motion. First one, v equal to u plus at. What is u? Initial velocity. What is v? Final velocity. What is a? Acceleration. T is time. Here the picture, here the body starts with the v, initial velocity, and goes to last point, that is it has initial final velocity is v, it takes time t, it accelerated with the uniform acceleration, that is a. Okay, so you just copy this one, figure also you just copy, here also in bracket also you have to mention uniform acceleration. Uniform acceleration bodies only we can apply these equations. A is constant, should be constant in all the equations. This is the first equation. So I will give one problem on this formula. You just copy it. Come on, copy and message me yes. So did you copy here? Okay. Now I will give you information. So what is the kinematic equation here? Equation of linear motion. This is the first equation we have, that is v equal to u plus at. V final velocity, u initial velocity, a acceleration, t is time. Here four variables are there. V u a t, v u a t. Right. Okay. I am giving one problem here. A car. Write the problem. A car starts with 20 meter per second. 20 meter per second, and it reached reached a point with 40 meter per second in 10 seconds. In 10 seconds. See, what is my question? A car starts with 20 meter per second and reached a point with 40 meter per second in 10 seconds. In 10 seconds, 20 meter per second goes to 40 meter per second. See, the question is here, what is the acceleration of the car? We have to find acceleration. So can you do this one? Can you do? Try it. Try first. Can you do? So what is here? A car starts with 20 meter per second and it reached a point with 40 meter per second in 10 seconds. What is the acceleration of the car? Come on, say and do the problem and give me answer first. Come on, yeah. What? See here, the car. This is a car. Here 20 meter per second reached. Here the changed 40 meter per second. The car starts with 20 meter per second and goes to 40 meter per second in time 10 seconds. So what is the acceleration? What is the acceleration? So for this one, v equal to u plus at, v equal to u plus at. We can apply here this kinematic equation. we are going to apply this kinematic equation, that is v equal to u plus at. v equal to u plus at. V is, what is v? 40 meter per second. U is 20 plus a into time 10 seconds. So here just 40 minus 20 equal to a into 10. 20 equal to a into 10. A equal to 20 by 10, that is 2 meter per second square. Is it? This is the answer. See, simply we did this one. Simply. See, my question is, I given one equation here, v equal to u plus at. V equal to u plus at. Here, the car starts with initial velocity u, then it goes. Finally, it reached velocity to v. Initially, it has u velocity. Finally, it reached u velocity. How much time it takes? How much time from here to here? How much time it takes? In the problem, we have 20 meter per second. Then goes to 40 meter per second. The velocity increased 20 to 40 in 10 seconds. In 10 seconds. My question is, what is the acceleration? So acceleration is nothing but change in velocity by change in time. We can do what we discussed in yesterday, acceleration definition, change in velocity by change in time. Otherwise you can use this equation of linear motion. This is the first equation, v equal to u plus at. I substitute v equal to 40, u equal to 20 plus a into time equal to 10 seconds. Then 40 minus 20, that is a into 10. 20 equal to a into 10. A equal to 2 meter per second square. So acceleration of the body is equal to 2 meter per second square. Okay. If you copied, then message me yes, yes, yes. Come on. Then only I will go to next problem. Come on. Message me yes or no. Respond, yeah. Message me yes or no if you copied this problem. Fast. Yes. One more. Okay. I will give one more problem here. Then you can easily do this one. For example, this is the second problem. A bus starts with 10 meter per second after 10 seconds it reached destination with 40 meter per second. So what is the acceleration of the bus? This is simple. This is simple. Is it? What is this? A bus starts here 10 meter per second, here 40 meter per second, here too it moved. Time taken is 10 seconds. So this is nothing but u, this is nothing but v. So why I am using u is the initial velocity, this is here final velocity. So time taken 10 seconds to change the velocity 10 to 40. So what is the acceleration? Same question. V minus, we will get v equal to u plus at. V equal to u plus at. V equal to 40. Here 10. A into 10 seconds. Then solve the equation. You will get the solution. So here 40 minus 10. A into 10. 30 equal to a into 10. A equal to 30 by 10, A equal to 3 meter per second square. This is very very simple. I given this a second problem to you. In this question also I asked only acceleration. Why I am giving this? You don't confuse and don't worry about these things. What is acceleration, initial velocity, final velocity? You don't want to confuse. You have to practice this question. That's why I am giving so many examples to you. Okay. If you finish this problem, you can message me yes first. Okay. Yes. No. Yes. No. Yes. Okay. Now, see, I will give one more problem to you based on this equation. Linear equation of linear motion is the first equation. So, say a bus starts with 10 meter per second. How much time? How much time it takes to reach its velocity 50 meter per second with acceleration 2 meter per second square. So this is the question. See, I am reading the question now. A bus starts with 10 meter per second. How much time it takes to reach its velocity to 50 meter per second with acceleration 2 meter per second? See, the body starts with 10 meter per second. It is moving. When it goes to the velocity of that bus, 10 meter per second goes to 50 meter per second. How much time it will take? 10 to for 50 see, initial velocity is 10 meter per second, final velocity is 50 meter per second. So the velocity increases to 10 to 50. So my question is, in how much time it will take to reach 50 meter per second? The body is accelerating with 2 meter per second square. This is the question. So here, this is the bus, this is the bus. Okay, here what happens here? 10 meter per second, here 50 meter per second. This is initial velocity, this is final velocity. So it is accelerating with uniform acceleration 2 meter per second square. 2 meter per second square. My question is, how much time it takes the bus velocity change it to 10 to 50? You do it, go for time, calculate it first. Come on. Is the question, have you understand? Okay, if you understand, you do this answer and give me first. You already said 20 seconds. Very nice, yeah. I will check it. You are very intelligent. V equal to u plus at. So I am changing here. What is V? 50. What is u? 10 plus a. What is a here? 2 meter per second. Time we don't know. Time we don't know. Is it? Did I substitute values correctly? Have I substituted values correctly? First we check it. The bus starts with 10 meter per second. How much time it takes to reach its velocity 50 meter per second with acceleration? So bus is moving uniform acceleration. The bus is moving in one direction only. That means linear motion. So we can apply this equation. Where we apply the equation, this is for linear motion. Then the body should has uniform acceleration, fixed acceleration, constant acceleration throughout the journey. It is going with 2 meter per second square only. A is constant value. Now u equal to 10, v equal to 50, a equal to 2 into t. Now we will check it. 50 minus 10, 2 into t, 40 in equal to 2 into t, 2 into t equal to 40, t equal to 40 by 2, that is equal to 20 seconds. T equal to 20 seconds. Good, very nice. Balu, you did well. Here the time taken 20 seconds. That means if the bus starts with 10 meter per second, in 20 seconds the velocity goes to increase 50 meter per second when the body is accelerating with 2 meter per second square. If the body is accelerating with 2 meter per second square, only the bus reaches 50 meter per second. This is the, here we got t equal 20 seconds. This is simple, you also already did. If you have any doubt, you can ask me in text box. Okay, if you copied this problem, you say me yes, then go, I will go to next problem. Okay, yes, right. Based on this question, I will give one more problem to you. This is the fourth problem. A car traveling with 30 kilometer per hour, 30 kilometer per hour, and reached its velocity to 60 kilometer per hour in 2 hours. So I don't want to give these things, already same question I'm asking. Traveling 30 kilometers and reached what here. A car traveling with 30 kilometers per hour, it travels for 2 hours with acceleration 3 kilometer per hour square. It traveling with 30 kilometer per hour, it travels for 2 hours, the acceleration with 3 kilometer per hour square. So what is the final velocity of the car? Do it, come on, write the problem here. A car traveling with 30 km per hour, it travels for 2 hours with acceleration 3 km per hour square. What is the final velocity of the car? Come on. The car starts, finally reached. The velocity is increased. It takes some time. With the acceleration, it is moving. Positive acceleration. In positive acceleration, the car speed is increasing. In deceleration motion, the car speed is decreasing. Here is the positive acceleration plus 3 km per hour square. So what is the final velocity? We have the information here. This is the car, starts with 30 kilometer per hour. Then we don't know this one, we have to calculate this one only. It travels for 2 hours. Then with the acceleration 3 kilometer per hour square. Okay, so this information we have now. U equal to 30 km per hour. We have to find final velocity of the car. It travels for 2 hours with constant acceleration 3 km per hour square. So use V equal to U plus AT. V equal to U plus AT. V equal to, we have to find U equal to 30 plus acceleration is 3 km per hour square into time is 2 hours. 30 plus 3 to the 6. You got V equal to kilometer per hour. Very nice. Very nice. You got same answer. Okay, very nice. You got 36 kilometer per hour. Is there any confusion? You can use this question easily. No. Is it or not? Yes or no? You can use this question easily. So we can find, use this equation, final velocity, we can find initial velocity, we can find acceleration of the body, we can time how much time it takes, that is t. So by using this equation we can find v, we can find a, t, whatever it is, by situation of the question. Yes. Okay, now I am moving one more question. Give me answer. I am giving one, I am asking one question. This linear equation of motion, these equations of linear motion can be used with constant acceleration bodies or not constant acceleration bodies. If constant accelerated bodies, give me answer constant acceleration bodies. Message me constant acceleration body first. Otherwise uniform accelerated bodies. Message me first. Constant accelerated bodies only we can use these equations of linear motion. Okay. Now we'll see second equation of motion. S equal to ut plus half at square. S equal to ut plus half at square. This is the second question. This is the second equation of linear motion. So these two equations we can apply only linear motion. The body has to move in one line of motion. Linearly it has to move linearly along x-axis, along y-axis. Only single one dimensional motion. So here s equal to, you write this equation. So what are the terms are there, what it refers, you will write here. Displacement u, initial velocity, t, time, v, isn't it there, v, no, a equal to acceleration, that is equal to s equal to ut plus half at square. S equal to ut plus half at square. Come on. Okay, right. If you copy this one, what is s, what is u, what is t, what is a, already you know these things. S equal to ut plus half at square. Ut plus half at square. Okay, okay, right. I will give problem based on this question. Here also say problem one. A body starts with starts with 20 meter per second with uniform acceleration 2 meter per second square for 10 minutes. So the question is how much displacement covered by the bus by the bus. See, read the question clearly. A body starts with 20 meter per second with uniform accelerating 2 meter per second square for 10 minutes. For 10 minutes. So full stop here. How much displacement covered by the bus? How much displacement covered by the bus? How much displacement covered by the bus? This is a question. If you copy, so now solution for this one. Okay. See here body starts with 20 meter per second, then it is accelerating with 2 meter per second square. 2 meter per second square. It takes time 10 minutes. That means this is the bus. This is the bus. It starts with 20 meter per second. It is moving with uniform acceleration. It is traveling for 10 minutes. How much displacement will cover? How much displacement will cover? If the bus starts with 20 meter per second, it is accelerating with 2 meter per second square for 10 minutes. What is the displacement cover? That means ఒక బస్సు 20 మీటర్ పర్ సెకండ్తో స్టార్ట్ అయ్యి యూనిఫామ్ యాక్సిలరేషన్ కాన్స్టెంట్ యాక్సిలరేషన్ 2 మీటర్ పర్ సెకండ్స్తో వెళ్తూ 10 మినిట్స్ ట్రావెల్ చేసింది. ఎంత డిస్టెన్స్ ఇట్ విల్ కవర్? హౌ మచ్ డిస్ప్లేస్మెంట్ ఇట్ కవర్డ్ ఇన్ 10 minutes? This is the question. See, the bus starts here. It is moving with constant acceleration for 10 minutes. It is moving with 20 meter per second. Initial velocity 20 meter per second. After that, it's accelerating for 10 minutes. Then how much distance will cover in 10 minutes? That is the question. So we have the information here. You will see here u equal to 20 meter per second. U equal to 20 meter per second. A equal to 2 meter per second square. T equal to 10 minutes. So here second also we just convert it 10 into 60 600 seconds. Then what is equal to what? This is the question. So I will do here. So I will do here. S equal to ut. U is 20 in time 600 second plus half into a 2 t square 600 whole square. Is it somewhat numerical? It is lengthy numerical. 2 6 are 12, 3 zeros plus half 2 to cut 600 whole square 36 4 zeros. So what you will get, 36 plus 12,000, 47. That means for 72,000 meters. If you convert into kilometers, 472 kilometer. That means it starts with 20 meter per second. The uniform acceleration 2 meter per second for 10 minutes travels. See how much you will get. 60 minutes, 60 into 10 into 60, 600 seconds, 12,000 meter, 12 kilometers here, half into a into t square, 36, 4 zeros, here 3 zeros. Okay, like this you will get the answer. Okay, it is moving with 2 meter per second acceleration. That's why we got big value here. Okay, so I will change here. If you copy this, I will change one more problem. It is accelerating with 2 meter per second. It is huge velocity, huge acceleration. That's why we are getting so much value there. So I will convert into. So one more problem. First you complete this one. Did you understand this one? Forget about this numerical value. What we are taking: initial velocity u, acceleration 2 meter per second, time is 10 minutes, then displacement of the body. Okay. Now I will give one more question here. See, so I am changing here only 10 instead of 10 minutes. I am using here 10 seconds. So you calculate for this one. Calculate for these values, this information. See, u equal to 20 meter per second, a equal to 2 meter per second square, time equal to 10 seconds. So we have to find displacement s equal to ut plus half et square, ut plus half et square, u is 20, t is 10 seconds. Now half into a to t square means 10 whole square, 200 plus 2 into 100, 2 to cut, 200 plus 100, 300 meter. You will get 300 meter. Very nice. Is it visible for you? No. Okay, up to here just substitute here. I will do here simple. 20 10 200 plus 2 1 2 plus 100, 300, that is equal to 300 meter. So if a ball starts with 20 meter per second with uniform acceleration 2 meter per second square, for 10 seconds if it travel, the bus will displacement covered by this bus in 10 seconds, that is equal to 300 meter. 300 meter. Okay, have you understand? Okay, right. So I will change one. I will give one more problem to you. Easy problem to you. Why? Because you have to habituate this one. So here 10 meter per second is accelerating with 1 meter per second for 5 seconds. This is third problem to you. Come on, do it. Do it fast. Do it and give me answer in text message. That means in chat box. Do it, yeah. U equal to 10 meter per second, A equal to 1 meter per second square, T equal to 5 seconds. T equal to 5 seconds. And what about S? S equal to ut plus half at square. What is u? 10 t 5 plus half into a into 5 whole square. 10 5 are 50. Here 25 by 2. Is it? Is it or not? Yes. You will get here 50, 12.5. Finally, you will get 62.5 meter. 62. But here, what you get? See what I have asked you. What did I ask you? U equal 10 meter per second, A equal 1 meter per second, sir, T equal 5 seconds. You have to find displacement here. S equal ut plus half at square, U is 10. U is equal 10, 10 into T equal to 5 plus half into A equal to 1, 5 square. 25 by 2, 12.5, 50, 62.5 meter. Is it? I think you are saying 500 meter per second. This is wrong, no? We don't want to calculate final velocity here. We want to calculate displacement. You have to use the second equation here. Second equation. So this is the last question. Today I am going to close the class. So tomorrow and after tomorrow you don't have any class. Okay. On Tuesday I will start the class for 2 hours, for 1 hour. So I will give now homework for you. Did you understand? Have you understand today? First message me, both of you, yes or no. I explained here today only equations of two equations. That is first one v equal to u plus at, one more is s equal to ut plus half at square. Have you understand? Yes. Can you utilize the equation for finding s, u value, v value, a value, t value? Yes or no? Message me fast. Yes or no? Okay. Right. I will give some homework for you. Here u, v, a, t, then s. Write this table. Find. See first. See, for all the questions I am not giving theoretical theory here. Just I am giving here decimals. See numbers. See, for example, u equal to 10 meter per second. A body starts with initial velocity. Finally, it reaches to 20 meter per second. Acceleration 1 meter per second square. It travels 5 seconds. How much displacement it covers? S equal to ut plus half at square. You have to use for this question. Second equation. First problem. Second. We have to find initial velocity. It reached 20 meter per second. It accelerating with 1 meter per second square. It travel for 10 seconds. It is this much only. You can find. Okay, right. Here we don't have this one. S we don't have. S value does not there. See what we have. You have v value, you have a value, you have t value. You have to find initial velocity for this question. This is a question. Here, this one. The third problem. 20 meter per second, 40 meter per second. Then you have to find acceleration. It travels for 10 seconds. It displaced 100 meter. The displacement of the body is 100 meter. S you have, T you have, V you have, U we have. You have to find acceleration of the body. Acceleration of the body. So this is the third. Next, one more. 2 meter per second goes to 4 meter per second, accelerating with 2 meter per second square. So here instead of it goes to 24, travels for 2 seconds, take at least 10 seconds, find s. We have to use second equation here. You have to use second or first, whatever it is. Next. Okay. 20 meter per second, final velocity also 20 meter per second, which travels for 10 seconds. How much final velocity? You don't want to calculate s here. What do you have to find? Yeah. These are the 5 questions. This is a table. We have to draw it. You have the mark it and find the blanks. Fill in the blanks. You have to find here in the first question displacement. Here you have to find initial velocity. Here you have to find acceleration of the body. Here you have displacement of the body. Here you have the find acceleration of the body. Just use 2 equations only. What we discussed up to now, u v equal to u plus at, s equal to ut plus of at square. By using these 2 equations, you find these values. Okay, have you understand the class? If it is good, you message me good, otherwise bad, then leave the class. Come on. First, if the class is good, you message me good, otherwise message me bad, then leave the class. First. Okay, right, boy. We'll meet on Tuesday. Okay, bye.